So hello, welcome. Today's plan is I'm going to go talk about the exam that comes up on Friday. You have an exam Friday at 2. It opens at 2. It closes at 3:05. The idea is this is a 50-minute exam. You have 50 minutes to do the exam, plus I give them a bonus 15 minutes to upload. I highly recommend that 50 minutes in, you stop, you take your pictures, you upload. If you want to see, I am going to be working through a PDF of the exam. That is what it would have been if we were in person. I kind of make the PDF anyways, even though it's not in person. If you want to know what it would have looked, what it's actually going to look like to you, if you go onto Vanco Hall and go down to the exam 1 fall 2020, this is what the exam will look like for you. It'll start with a little bit of info page, and then we'll have each problem on its own page. General ideas, you do the work on a piece of paper, take a photo of it, and upload that work. Each problem will get one photo. And after you upload them all, I'll grade it all later on. This version up here for last semester's exam, there's no need to do it. It's just there so you can see. If you want to see how long it takes you to take pictures, transfer, and upload, go for it. I'm never going to look at what anyone uploads here, other than maybe some sick curiosity, see if anyone uploaded anything weird. So feel free to try to upload something here just to make sure you know what you're doing and you can do it in time. 4 questions. Each one is going to be worth 25 points to have a total of 100. Any question about the exam in general before I start going through like what type of stuff to expect? Okay. So 4 questions. As I said before, the first one will be free fall. Now, as I go through, I'm going to try to solve these problems, but as I solve them, I'm also going to talk about how I grade and the mentality you can expect and what kind of things you can expect on your exam. But as I said, the first problem will be free fall. If it's free fall, it will mean it involves these equations right here. That these equations, that's the free fall equations. And what I did last time was I said, in the very beginning of Winter Soldier, Captain America jumps out of a Quinjet into the water below. Let's say Cap takes a slight hop off the Quinjet, giving him an upward initial velocity of 4.16 meters per second. What that means is V naught is 4.16 meters per second. And it's upward, so it's positive. He starts 482 meters above the water. That means he starts at a height of 482 meters. What's his velocity when he hits the water at the bottom? Well, at the bottom, he's at the bottom. I'm going to say that's my 0 point. And I ask, what is the velocity? And part B, how long does it take? Does that make sense? So when you're solving a kinematic equation or a free fall equation, it turns into a matching game. And what I'm going to do, and you know what, let's zoom in here. What I'm going to do is I'm going to find which of these equations match what we want. The first bit is to solve for V. And so if I'm going to solve for V, I want one of the 2 equations with a V in it. So that's either going to be this one or this one. Now, initially, I don't know time. I'm solving for time later on, but I don't know it yet. And so that means I have to use the equation without time in it. And so this has to be my equation. V squared equals V naught squared minus 2G y minus y naught. Now I'm solving for V, so I barely have to rearrange. If anything, it's just square root both sides. Although I just plugged in numbers right away for once, something I normally say not to do, but it's just square rooting. Y is 0, y naught is 482 meters. So V is the square root of all that stuff and is 97.3 meters per second. However, I gotta remember he's going down, he's falling. Because he's moving downwards, that's a negative value. Because keep in mind, anytime you take a square root, there's two possible answers, a positive one and a negative one. And because he's falling, I have to use the negative one. Okay. Sorry, I had another exam that was a second ago. So I'm kind of, I have an exam that's just closing right now. So I'm kind of multitasking. So I apologize for that. And that would be my answer to part A. I knew it had to be that equation, once again, just because I'm matching. Now, part B says, what's the time? And if I want to solve for the time, I can use either the top or the middle equation because both of them have t in it. I'm going to use this one because it's a hell of a lot easier. This guy has a t and a t squared. That's just complicated. And I'll just say v equals v naught minus gt. I'll subtract v naught from both sides. V minus v naught equals negative gt. I'm just going to get rid of my negative sign because it bothers me. V naught minus v equals gt. And divide both sides by g. So a few things here. Well, any questions on this before I talk about grading? Okay, few things here. To get B correct, you needed A correct. That if you didn't get negative 97.3, you would have gotten the wrong number here. I try not to double hit. If you get part A wrong, and you do everything 100% correct for part B, but just got the wrong answer because you got the wrong answer earlier on, I won't hit you again. If you got 20, negative 20, and then you plugged in negative 20, I would check the math and see if this answer matches. And if so, give full credit. Also, I give heavily with partial credit. The points I gave last time was 2 points just for realizing, he started above the 0 point. I gave 5 points just for writing this equation, not using it, just writing it down. I gave 5 points just for writing this equation down. I gave 5 points for this answer. I gave 5 points for this answer, plus a bonus 3 for the negative, which is actually less partial credit than I normally like to give. The final answer being 8 points kind of bothered me, but there was just so few steps I didn't have more places to give partial credit. So once again, the first problem will be free fall, and just writing these equations down is points. Keep that in mind. Now, it obviously won't be exactly the same on your exam. I might have to use that top equation that I didn't use here. I might use the same too. I might do any. I actually don't remember what the first problem is. That's bothering me. Nope, completely lost in my mind. Any questions though? The second problem will be projectile motion. In projectile motion, it's the same kinematics equations. It's just now we are going to say that acceleration in x is 0. And also use the idea that vectors can be broken into components. The problem last time, which actually, let me go back to this, was this. That Toph from Avatar the Airbender, or Toph, sorry, has a scene where she flings a stone at a catapult on another ship. That's the scene right there. And I say, She flings the stone at a ship 124 meters away. She launches the stone at a velocity of 99.8 miles per hour. Okay, hold on right there. You see, I don't have a problem for chapter 1, but chapter 1 is still going to show up somewhere. And where it'll probably show up is unit conversions. I normally do 2 unit conversions on the first exam. If I say this velocity is 99.8 miles per hour, I need to convert this. Well, keep in mind that 1 mile is 1,609 meters. We're going to put miles on the bottom here so that they cancel. And 1 hour is 3,600 seconds. We're going to put hours on top so those cancel. And I'll just multiply through. 99.8 times 1,609 divided by 3,600. Sticking to the grading rubric, it was 5 points for doing that unit conversion. I normally do 5 points for each unit conversion. So if there's a unit conversion, that's normally a quick 5 points. Now, that says she launches the stone at a velocity of 44.6 meters per second at 20 degrees. So I'm going to pause there again and say I never care about V naught X. Oh, sorry, I never care about V naught. V naught doesn't matter. What I care about is V naught X and V naught Y. You see, V naught X will be V naught cosine of theta, as long as your angle is measured from the horizontal. And V naught Y will be V naught sine theta, as long as your angle is measured from the horizontal. Plus 3 points for writing this down, plus 3 points for writing that down. Can I restate something again? The second problem will be projectile motion. You cannot solve a projectile motion problem without these equations. If you blindly write these equations down, I will give points. I don't know if I can make that much more obvious of what I'm trying to give away here. But either way, I can plug in the numbers. V naught is 44.6. And the angle was 20 degrees? 20 degrees. And V naught Y would then be 44.6 sine of 20 degrees. Um, 2 points for this number, 2 points for this number. Now, projectile motion always comes in one of 2 flavors. Either I will give you X and ask for Y, or I'll give you Y and ask for X. In this problem, it says she launches the stone at velocity, blah, 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 from 82.1 meters above the water. Assuming she was, oh, sorry, I skipped that part. Begin to fling a stone enemy ship or catapult 124 meters away. Just look at my diagram. I show it's 124 meters across. That means X equals 124 meters. And what I ask for is how high above the water does the stone hit the catapult? Which means I'm asking for Y. In a projectile motion, either I'll give you X and ask for Y, or I'll give you Y and ask for X. That's one of the things that could be different between this exam and the one you're going to get on Friday, is I could go either way. Here I gave X, ask for Y. On the one on Friday, I might do the same, give X and ask for Y, or I might do the opposite, give Y and ask for X. If you want one where I gave Y and asked for X, in the homework, there was Jessica Jones throwing a call, and there's a few other things. In the example problems, there was someone throwing a Pokeball to Charizard, and in the notes, it was the movie Speed. Is that a question or?
Oh no, sorry. I was logging on.
It's okay. And so how we're going to solve these is we're going to use our X and Y equations. We know X, so I will use X to get time. We'll say X equals V naught X T. Side note, just writing this equation down, it was 3 points. If I divide both sides by V naught X, that means time is X over V naught X, or 124 meters over 41.9103 meters per second, which is 2.9587 seconds. 2 points for getting that time. Now I know how long this thing is in the air. Now that I know how long it's in the air, I can solve for the height, because y equals y naught plus v naught yt minus 1/2 gt squared. That's a really nice color. So it would be the initial height. I said it started 8.21 meters up. V naught y, seriously, hi PB. Sorry, pause for cat. PB, you can't be there right now. Nope. Okay. 15.254 meters per second times time. No. 2.9587 seconds. This is the rest of this class is going to be me fighting my cat.
I got $10 on you.
So I kind of ran out of time, space there, so that's that t squared is on the bottom. And it's kind of out of focus. Come on, focus over here. And I'll just do that math through. 10.4 meters. Well, because I didn't show it, it was 3 points for this equation and 2 points for the final answer. Now, as I said, I might go the other way. I might instead give y and ask for x. I talked about problems similar to that already. If I do that, just go the other way. Also, I will say, note that because I grade heavily with partial credit, what that means is that if you jump to an answer, if you just wrote 10.4 on the page and don't show this, I will only give 2 points. I don't care if you can spit out an answer. I want to make sure you understand the process. When I grade by partial credit, I mean that. I want to see the steps. I want to see the work. And if you skip the work, I will not give full credit. Any questions there for projectile motion? Okay. The third problem will be, without a doubt, no surprises, forces without friction. This might mean equilibrium. This might mean not equilibrium. This might mean a ramp. This might not mean a ramp. It could be any of those things. Which one's it going to be? I'm not going to tell you. But it'll be something. I can guarantee that much. What I did last semester is I went for the Mandalorian. This was before season 2 also. The Mandalorian from the show of the same name uses a jetpack to fly through the air. He does so by using his jetpack to apply a force F at an angle of 60 degrees, as shown below. What force must the jetpack be exerting to keep the Mandalorian at a set height, neither lowering or rising? And I give the weight. Oh, that's in pounds. I said he weighs 265 pounds. Okay, I don't give a shit about that. 265 pounds. I need to convert that to kilograms. Well, 2.2 pounds is 1 kilogram. So if he weighs 265 pounds, that means a mass of 120.455 kilograms. Side note, where's my grading rubric? My grading rubric is just like a mess of me writing things all over the place. +5. Oh, side note, the typed version of these answers are on Banco Hall. So you can get a typed version. They look a little something like this. But that is on Banco Hall. So I ask, what force must the jetpack be exerting to keep him at that height, neither rising or lowering? And then in B, I say, what's his acceleration? Now, if he's not rising or lowering and is accelerating, I can assume his acceleration is an x. And this is a force problem. So I know what equation I'm going to use. If it's a force problem, the equation is F equals ma. That's what it is always for a force problem. The third problem will be a force problem. And if I just write that down, that's 3 points. And I start all force problems the same way, a free body diagram. See, what I can say is as the Mandalorian flies, he's being pushed up with a force F that's already drawn here. But there's going to be gravity. And really, I should comment that maybe we're going to assume the same gravity as Earth because we're not on Earth, but whatever. If I don't tell you anything about a planet, assume Earth gravity. And so I can say gravity will pull him down. Well, gravity is mg. But the thing is, if I use a standard coordinate system, you know, x, y, I can say that gravity is directly in the negative y. But this first f is up and at an angle. Since it's up and at an angle, I'm going to want to split it into components. I'm going to say instead of that, let's turn it into two pieces. Let's turn it into an fx and an fy. Well, I'll just split it. And I'll just say fx and fy can be solved. Well, f of x equals f cosine theta, and f of y equals f sine theta, because my angle is measured from the horizontal. Also, I should write this, I guess, up here. Free body diagram was worth points. There was +1 point for each vector on the free body diagram. So 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're up to 15 points out of 25. Haven't done any math yet, and I'm at 15 points out of 25. Now keep in mind, in the F equals ma equation, that's really two equations. What was that? Okay. That's really two equations. The sum of forces in x equals mass times acceleration in x, and the sum of forces in y equals mass times acceleration in y. Now, that's what I'm going to use. And I'm going to start with my y equation this time. I normally start with my x just for no apparent reason. But the first bit says, what force must the jetpack be exerting to keep him at the set height, neither lowering or rising? If he is lowering or rising, that's talking about acceleration in y. And if he's not changing his height in y, if he's stationary in y, that means he has no acceleration in y. And what I would do is say, okay, his acceleration in y is 0, and I'll look at my free body diagram. And I say, in y, I know the sum of forces in y is always the forces up minus the forces down. And so I'll look at my diagram and say, what's up, what's down? Well, looking at that picture, I've got to be careful because it's sum of forces, but this is sum of. That my forces up is F sine theta. My forces down is mg. And that'll equal 0. Plus 2, plus 2, plus 1. I can rearrange that to say F sine theta equals mg, and divide by sine theta, say F equals mg over the sine of theta. Or 120.5, I'm just rounding, 9.81 meters per second squared over the sine, was it 60? 60 degrees. Really, this was 1364.47. But I went to 3 sig figs. 1 point. 1 point for the answer. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We're at 21 out of 25. Part B says when that force is applied, what's his acceleration? Well, if he has no acceleration in y, his acceleration has to be in x. And so I'll look at my free body diagram, say right minus left. To the right, I have f of x, or f cosine theta. To the left, I got nothing. So that's it. That's my only force. And that has to equal ma. Plus 2 points, plus 1 point. And if I divide both sides by m, I'll get that my acceleration is f cosine theta over m. Or 1360 newtons, cosine of 60 degrees, over 120.5 kilograms, which is 5.66 meters per second squared. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Yep, 25 points. So he's going to adds up. Now, the third and fourth problem will probably be the harder problems on this exam, because freefall is just, hey, just plug into a kinematic. Projectile motion is, here's a set process, follow it. It's the exact same way every time. That's also true for forces, but it's a little more nebulous. It's going to be make a free body diagram. Once you have a free body diagram, solve for sum of forces in X, solve for sum of forces in Y. As I said, I could change it up. I might put a ramp in here. If I put a ramp in here, look at example problems on Monday. There was someone sliding down a hill on a tray. Homework, it's someone being pulled up a ski slope. In the notes, it's Sisyphus pushing a boulder up a hill. I could do something like Spider-Man hanging that we did on Monday, or not hanging, but hanging from the 2 strings. There's a lot of things I could do. Look through the exam, the homework, the practice problems. Questions? I just looked at the clock and realized that I'm apparently going quickly. I'm sorry, I did not realize. Please yell at me when I go too fast. Once again, I don't see any of you, so it's hard to judge. I work better with an audience. The last problem will be, without a doubt, I'm telling you now, will be another force problem. But the last one will involve friction. Once again, it might include a ramp, it might not. Which one I go for really depends on how I felt at the time I wrote the problem. And because I have the memory of a goldfish, I can't even tell you what it's going to be. I literally don't remember. What I can remember is around the time this exam happened last semester, I was really obsessed with Last of Us Part 2 at the time. I'm one of the few people who uber enjoyed the game. And it says, when exploring Seattle in Last of Us Part 2, you find yourself as Ellie sliding down a muddy hill, assuming the hill makes a 50-degree angle. If the coefficient of kinetic friction between Ellie and the mud is that, what's the acceleration down the slope? Okay. Well, it's a force problem. So we know we're going to use F equals ma. 3 points just for writing that equation. Didn't even have to read the problem. I could have just said, hey, it's the fourth problem on the exam within that equation and gotten 3 points. Like all force problems, I am going to need to go and make free body diagrams. And so I'll say what forces are acting on. And here, I'm going fast. I'll have you guys say. What forces are acting on Ellie when she slides down this hill?
So we have the normal force of the ramp pushing up on her. We have gravity pulling her down. And then we have friction pulling her up. And I think that's it.
And that is it. And instead of labeling everything individually, let's just do that. Yay, screenshots. And I can say, there it is. The thing is, this is a ramp. In a ramp, it is easier to use a tilted coordinate system. I can't quite tilt at an angle. It is easier to say, instead of beep, 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 dunt, 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 that instead of using this, of just turning the whole page and using this. And say my normal force is straight up. My friction is straight to the left. My gravity is at some weird component. And what I'm going to do is I'm going to break gravity into components. Now, normally, x component is cosine, y component is sine. But keep in mind, for ramps, this always goes backwards. That in ramps, I'm just going to put it over this picture. In ramps, your x component will be sine, your y component will be cosine. This is because the angle that we care about here, and let's here just doot, is going to be this one right here and is measured from the vertical. Even though we found it here, this angle is the same as that one. And it ends up being measured from the vertical. And so what I'm going to do is I'm going to say my free body diagram is like this guy. Points. I can't read my handwriting. Yep. Point wise, it was 1 point for each of these vectors. +1, +1, +1, +1. And there was an extra just +2 for saying this was sine 50, not cosine 50. And this was cosine, not sine. So if people were like gravity and x, they would, but it's just knowing the sines and cosines where they went. Now, if she's sliding down the ramp, I can assume she's not going up this way or down into the mud, although that wouldn't necessarily be a great assumption because it's mud. What that means is there will be no acceleration in y and some acceleration in x, which is what we want to solve. Really, I should have put those flipped because I always put my x on the left. And I'm going to say F equals ma is really two equations. The sum of forces in x is mass times acceleration in x. And the sum of forces in y is mass times acceleration in y. But I just said that's 0. And I'll say, okay, we can make these equations. See, in x, my equation is always right minus left. And looking at my picture right there, my right is mg sine 50. My left is friction. Point wise, that was 2, 2, 1 again. Yep, it was 2, 2, 1 again. +2, +2, +1. Now in y is up minus down. So up, I have n. Down, I have mg cosine of 50. And that equals 0. And this is also worth a total of 5 points, or 2, 2, 1. Thing is, as of now, the y doesn't seem important. I want to solve for this a. But if I want to solve for this a, I need that friction. But I know that the force of kinetic friction, is mu of kn. You know what? I'm just going to do this. 2 points for writing that down. And I'll plug that in. mg sine of 50 degrees minus mu of k n equals ma. If I want to solve this, I need to know what n is. And if I want to get n, I'll just go back to my y equation and say n minus mg cosine 50 equals 0. That means n equals mg cosine of 50. And I'll just plug that in for n. I was saying this left equation, this is now mg sine of 50 degrees minus mu of k times n. Well, once again, n is mg cosine of 50 degrees. And this will equal ma. I can divide both sides by m. If I divide both sides by m, they all cancel out. And I get that my acceleration is g sine of 50 minus mu of k times g cosine of 50. Three, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yep, 25 points. As I said, I always like to make sure. Now, the problem's not going to be identical. I'm not going to give you someone sliding down a ramp with friction. But with friction, I can do a lot of other things. In class, we did Krampus pulling something on, yeah, it was a class. On On the homework, there's one just like it with Groot. I could do something like that. In class, I did the Fast and the Furious call, pulling a safe. And on the homework, there's one just like it with Rey from Star Wars pulling a lightsaber. I could do one just like that too. Or I could do something completely different and just fuck with you all. I got a lot of options. I will say this. This is the first exam I've given, I think in 7 years, that doesn't have a Marvel question on it. Because I didn't want to do WandaVision because it was too new and I thought too spoilery and nothing else has come out recently and I was running out of ideas. So that's a fun fact. No Marvel. I made up for it with a lot of other things. But I could do something different. But no matter what I do, no matter what I throw on here for the fourth problem, remember to base it off F equals ma and friction. And when you do it, make your free body diagram. That's last semester's exam. I still got 15 minutes, 14 minutes. So I'm willing to do other problems if there's something people want to see. Or answer any questions people have. So at this point, I'm going to open it up. What can I do to help you with the exam?
Can you do any other variations of questions that are like problem 1 from this exam?
Problem 1. Yeah, sure, let me find one. Want to grab one I haven't done before. Let's see. I did the fall 2020 problem 1. So let's just go to fall 19 and see what the problem was. I don't even know. Oh, that's nearly identical to the one I did. Let's not do that one. Like, it was an Assassin's Creed problem that was, yeah, nearly identical to the one I already did today. So let's do something different. Sure, that works. This problem is going to date itself. Because there's a Fortnite question. A game I never really played, but was such a big deal at the time that I did a Fortnite question anyways. Second one on this exam matches my short. So, here's another example for problem 1 problem. And it says, the launch pads in Fortnite can launch players straight up with an initial velocity of 39 miles per hour. Okay, we're going to stop right there. 39 miles per hour. I got to do a conversion. I want to cancel out miles to get meters. Well, 1 mile is 1,609 meters. I got to cancel out hours to get seconds. Well, 1 hour is 3,600 seconds. When I do that conversion, I get 17.43 meters per second. Okay, so it says, the launch pad in Fortnite can launch players straight up with an initial velocity of that. So this is V naught. What is the maximum height of the player? If I were to find the maximum height, what that means is I am looking for this spot right here. And what I know is at the maximum height, whenever I hit the max, that's what I'm in between going up and going down. At that point, my velocity is 0. And if I'm going to assume I started on the ground, and my question is, how high is that? And so I'm going to look at my equations and do my matching game and say, hey, time didn't come into play again. Time does sometimes come into play, I promise, but didn't this time again. And so I'm going to once again use this equation. And I'm going to solve for y. Now, I like to plug in my zeros right away. V is 0. V naught squared is naught. 2g. Y naught is also 0. So just plug in zeros, I get this. I'll add 2gy to both sides. And then divide both sides by 2g.
Can you slow down for a second?
Oh yeah, sorry. Where'd I lose you?
Just this last step.
Okay, so what I did here is I just divided both sides by 2g. By dividing both sides by 2g, that lets these cancel, giving me y alone.
I got you. And you just solved v sub 0 squared over 2g.
Yep. Where my v sub 0 is the converted version. And g is g, which is always g.
So now that's your distance?
That's
your
the distance. Well, that's the same thing.
Right, okay. So you're plugging that into like the y equals y sub 0, that one?
No, that's my answer. I want to know how high they got. How high they got is going to be y.
Oh,
so
okay. So question B is how much time do they spend in the air?
Yes. Question B, which I can do now. Question B says, how long do they spend in the air? Total time from ground to ground. If I'm going from ground to ground, that means I'm going from y naught equals 0 to y equals 0. We know v naught, that didn't change. And we want t. And what I'll do is I'll go my matching game and say, now we need an equation with time in it. And I chose to use this top one because I said I didn't know Vy. I didn't write down Vy. I actually do know Vy. Vy is negative 17.43, so I could do it that way also. And maybe I'll show that after. But I use this top equation. And I said, if I want the time to go from ground to ground, I'll just say y equals y naught plus v naught yt minus 1/2 gt squared. Plug in my zeros. I can then add 1/2 gt squared to both sides. I'll then divide both sides by t. Multiply both sides by 2. And divide both sides by g. That was a really bad 5. This is a very different problem, but it's still kind of the same logic. Write down your knowns. Once you write down your knowns, try to make things match. I don't know the grading rubric here. I don't have it on me. Honestly, let's see, spring 2019. This one was spring 2019. Yeah, this was done in person. So it would be in my office at school anyway, so I don't even have it home. In the before times when I saw people. If you could have also done it using this middle equation and saying Vy is negative 17.43, people who did it that way, I also gave credit to, full credit. It doesn't matter which way you do. I'm not gonna be like, you must do it my way. You can do it either way. But that is how it was done. All right. Any questions on this problem? I do not have enough time to do another problem. We only have 6 minutes left, but I do have time to answer any other questions people might have. So not counting doing another problem, is there any other questions that I can help with? Some other points of interest. Numbers all randomized. You're not going to all get the same numbers. Please do not work together. I will say, like, the solutions will show up Friday night at 5 p.m. I like to make it later in the day just in case of weird mess ups. During the exam, I will be on Zoom. If you have any questions, you can ask me. I'll be on there. You don't need to be on Zoom if you don't want to be. Because I randomize numbers, that you might find that the numbers on the solution key don't match the numbers you got. That's because the numbers are randomized. The whole process should be the same except for the final bit where I plug in values though. So you can check those values yourself. I hope to grade it Friday night. If I do not grade it Friday night, I will grade it Saturday. We'll see. Depends on how crazy life goes. Recently, it's been pretty goddamn crazy. Anything else I can help with? Well, if you guys don't have anything else, I will stop there. Have a good day. Don't forget homework due tonight. Don't forget lab due tomorrow. And see you at the exam.
Thank you.
Oh, that's what I meant to do. I meant to stop recording.